to our show! I am professionally trained Chef Holly Huang.
And I'm professionally trained Chef Sabrina Rainsbury.
And today we are going to tackle an infamously challenging recipe.
Today's episode is
Mac with Math! Proper macaroni and cheese may be difficult to make, but it can be an extremely healthy snack with a strikingly low calorie content. How many calories are in this dish? Let's find out!
The temperature in Fahrenheit of a sample in a furnace for residue on ignition test is demonstrated by the following equation, where T is the time in minutes. What is the average value of temperature over the interval T equals to 0 and T equals to 30? Well, we simply need to take the integral of the given equation and multiply by the distance over the interval. The integral would give you 31,500 and the distance over the interval is 30, so 1 over 30 times 31,500 would give you 1,050. So there are 1,050 calories in this dish. Healthy, easy peasy.
So to begin, we will need to pour water into our pot. How much water do we need to pour into this pot? Let's find out!
To find the amount of water that we'll need to calculate the volume of the solid formed on a given interval between two given curves. So we'll need to set up an equation, the integral from the lower limit of 8 to the 1/4 to the upper limit of 32 to the 1/4 of f of x minus g of x squared. From there, you'll need to simplify the integral and then take its antiderivative. The next step is to plug the upper limit back into the function and then from that subtract the lower limit plugged back into the function so that you get your final answer of 6.
According to the recipe, we'll need 6 cups of water. The next step is to boil the water. But how do we know when the water's boiling?
Great question! Let's find out!
To find water's boiling point, we need to find the area bounded by the following curves, from x equals to 0 to x equals to 25 pi. So, an area bounding problem. Oh, top minus bottom. So the top curve as shown in this picture here is the red curve, and that's the first graph, and the bottom curve is the second graph. So that would be the same thing as two of those two graphs together. And to simplify the problem and make calculation easier, I found the area of the first little half circle thing and multiply it by 25 because there's 25 of them on the top, and then multiply it by 2 again because there's 2 of those 25 at the bottom. Doing some math, and I get 100. Easy peasy.
We just calculated that the water reaches its boiling point when it reaches 100 degrees Celsius. So now, using a thermometer, put it into the water and wait till it reaches 100 degrees Celsius. Now we need to add the macaroni. But how much? Let's find out!
To find the amount of macaroni that we need, we're asked to find the total distance traveled by an object between the times t equals pi over 12 and t equals pi over 4. Since velocity is the derivative of position, we'll need to take the antiderivative of the given function. Now you must manipulate the trig functions and use u substitution in order to find a function with a known antiderivative. Next you plug in the upper and lower bound into the antiderivative and then solve to get 1.
We will need precisely 1 box of macaroni. Now we need to allow the macaroni to cook for some amount of time. But for how long exactly?
Let's find out!
To calculate the time you need to wait for the macaroni to cook, you need to find the fifth derivative of the following. Well, this is pretty simple. When you take the first derivative, the last term disappears. When you take the second derivative, the second to last term disappears. Following the trend, you can see that you only need to take the derivative of the first term 5 times. After doing that, you will get 15 over 2. Easy peasy!
The macaroni must boil for 15 over 2 minutes, which is equivalent to 7.5 minutes!
Using a strainer, carefully drain all the water out of the macaroni and then pour the macaroni back into the pot.
Now comes the more complicated part. We need to add some butter. How much butter do we need? Let's find out!
To find the amount of butter that we'll need, we'll determine the x value at which the given function has a change in concavity, or has an inflection point. Since the inflection point is the second derivative, we need to take the first derivative using the known derivative of arctan. Then we need to take the second derivative by using the quotient rule. Once you have your second derivative, you'll need to set it equal to 0 in order to solve for x, which here equals 4. To ensure that it is actually a point of inflection, you'll need to use the line test and determine that there is a change in signs before and then after 4.
We will need to add 4 tablespoons of butter to the macaroni and allow it to melt. Then, we're going to need to add some milk.
But wait! How much milk do we need? Let's find out!
To figure out how much milk we need to add, we need to find the slope of the line tangent to the following equation at the point 2, 0. To solve for the slope of the tangent line, we'll take the derivative of the given equation, and because it has both x and y, we'll need to use implicit differentiation. Plug the coordinates for x and y of 2 and 0 back into the equation in order to find your y prime value, which is 1 over 4, and your slope of the tangent line.
We will need to add 1/4 cups of milk to the macaroni. And since we all know that we can't have mac and cheese without the cheese, we should probably add some cheese. But how much cheese do we need?
Let's find out!
To find out the amount of cheese you need to add, you need to solve this problem. You are given a g of x and h of x graph and are asked to find a h prime of g of pi over 2. G of pi over 2 would be sine pi over 2, which would be 1. And h prime of x is calculated to be 1 over radical x. Plugging the 1 in would be 1 over 1, which will give you 1. Easy peasy.
We will need exactly 1 package of pre-packaged cheese sauce.
Very smoothly, we need to now stir the macaroni. But how do we know when to stop stirring? Let's find out!
To find out how many times we need to stir the macaroni, we need to find the value k for which the following limit exists. Factor in the denominator and we can see that there is a whole at x equals to 3. So in order for the limit to exist, we must be able to get rid of the whole. So using synthetic division and assuming 3 as a solution, we get negative 8 at k plus 40 as the remainder, setting that equals to 0 because if it's a perfect solution, there's no remainder. And we get k equals to 5. To check, you simply need to plug in the k value into the top expression. And as you can see here, x minus 3 is on both the top and the bottom, and you can find the limit from then. Easy peasy.
We need to stir the macaroni exactly 5 times. Now, for extra flavor and extra health, we need to add some salt. But how much do we need? Let's find out!
To know how much salt we should add, we're going to find the absolute maximum of the given function on the interval -4 to 4. Since this is an absolute value function, we'll need to find the domains of the piecewise function, which consists of both a positive and negative function. Once we do that, we'll need to take the derivative of each and simply set that derivative equal to 0 in order to solve for the x value. For both the positive and negative version of the function, the x value is equal to 1/2. Although this shows that x is a critical point, it does not exactly show that it's the absolute maximum. To find the absolute maximum, we're going to have to take the endpoints into consideration and then plug them into the initial equation to find their y value. But still, we will end up finding that the maximum value of 25 over 2 is at the x value x equals 1/2.
We should add not 1, not 2, but half of a pinch of salt.
Huh, can you believe it? We actually did it!
Here we have our macaroni and cheese. But how many people can this feed?
Let's find out!
After eating some delicious mac and cheese, little Johnny went to the restroom. He discovered that the amount of servings that he ate is equal to the volume of his poop. He then proposed an equation to recreate his poop as the following. If 1 centimeter of poop is 8.88 units, how many servings did he eat? Well, judging by his equation, we can tell that it is a curve rotating about the x-axis. Using a calculator, you can calculate the integral, which would give you 669.232. Multiply that by pi and you get 2,102 unit cube. And now we need to do the conversion. Dividing the number 3 times by 8.88 unit would give you 3 centimeter cube. Easy peasy.
Well, we can serve 3 people with this recipe of macaroni. But more likely, we'll just eat them all by ourselves.
Thank you for tuning in to today's episode of Math with Math.
We hope this has been a great help.
Join us next week for another challenging recipe.
Deviled eggs with derivatives. See you then!